It's not every day that working on one video leads straight to making another one, but that's exactly what happened here. I was deep into Sky Reels, playing around with images I'd already created, when I suddenly thought, wait, what if I made new images instead? And then I remembered. I had downloaded Lumina 2, tested it once, and never touched it again. Until now. Why are we sleeping on this? Seriously, this is the stable diffusion model we never got. Small, fast, and a perfect blend of SD 1.5 and SD Upscale. It has the artistic feel of 1.5, the realistic vision of XL, and it follows prompts like Flux. It's like some mad scientist took DNA from all three, mixed them together in a test tube, and created a leaner, meaner version. Oh, and it gets better. It's natively supported in ComfyUI. That means you can use ComfyUI nodes with it just like you would with any other model. So here's the workflow. But before we dive in, take a second to like and subscribe. It really helps with the algorithm, and honestly, it keeps me motivated to make more videos like this. Alright, back to it. The workflow is made up of 5 groups. The loader group, the text-to-image group, the image-to-image group, the ultimate SD Upscale group, and the fast upscale group. If you're in a hurry, the fast upscale group is a great way to quickly upscale your images without spending too much time on it. I'm going to start with the text-to-image group and end with the SD Upscale group. But first, let's quickly go over the loader group. So, the loader group is where we bring in all the core components. First up, we have the GGUF loader for the Lumina 2 quantized model. Now, this isn't the GGUF node you might be used to. This one is by Calculus, and I'm using it here specifically because it supports Lumina 2. Right below that, we've got the model sampling ARA flow node. This is where the shift happens. I'll explain how this works when we go through the text-to-image group, but just know that this is what controls how the model interprets your prompts. Some people like using the Flux model sampler, but honestly, I'm happy with this one. It's super simple and only has one parameter to adjust. Next, we've got the clip loader, and I'm running it with the Gemma 2 model. I can't wait to see how fast this will be with a quantized version. Then there's the VA node for Lumina 2's VAE, and I'm using the FP8 version. This is basically responsible for decoding the images properly so they come out looking as good as possible. And finally, we have the large language prompt bypass. This is important because it helps with performance. You don't want it running in the background if you're using your own prompt. Alright, that's the loader group. Now let's move on to the text-to-image group. The first thing you're going to notice is the prompt switch. This basically lets you toggle between 2 options: your own manually written prompt or a large language prompt. If you set it to 1, it'll use your prompt. If you set it to 2, it'll use the LLM's prompt. Now, quick note here. If you're writing your own prompt, you should go ahead and disable the LLM prompt. Technically, you can leave it on, and it won't interfere with the generation itself, but it will slow things down because it's still running in the background. So, if you don't need it, just bypass it to speed things up. I'll explain the rest while we generate the images, but here's what I really want to test: how well this model understands complex instructions. Since it's using the Gemma 2 model, I want to see how good it is at handling different types of prompts. I'm going to test it with 4 different kinds of prompts. First, a simple prompt. Second, a detailed, natural language prompt using the LLM. Third, a highly complex, vivid, layered prompt. Basically, something convoluted to see how it handles nuance. And fourth, an art style prompt, where we'll ask for a specific look or aesthetic. Before we do that, though, I need to clarify a few things. Starting with the LLM prompt group. This group is made up of a few key parts, the first being the model loader. Right now, I'm using the Mistral model for this. Setting this up is pretty straightforward. You just need to add the model's name exactly as it appears in your Ollama list. If you're not sure what that is, here's how you find it. Go to the Start menu, type CMD, and open it. Once you're in, type Ollama list. Hit enter, and this will do 2 things. First, it'll show you a list of all the models installed on your system. And second, it'll automatically start the Ollama server. Now, just look through the list, find the model you want to use, copy its exact name, and paste it into the model loader. That's it. Right below that, we've got the Load Persona node. This is really useful because it lets you quickly load different system prompts without having to type them out every time. Especially if you have a long system prompt, this makes things way easier. For this, I'm using the Lumina 2 prompt assistant I created. If you want to use the same one, make sure the is enabled option is set to true. This activates the node. If you'd rather use your own system prompt, you can set it to false instead. I'll include the persona file with the workflow download. Once you have it, just place it in the LLM Party Custom Nodes folder inside the persona folder. That's where it needs to go. Next up is the general link node. My prompts always start with two things, subject and style. For the subject, I describe exactly what I want. And for style, I usually put either realistic or a specific art style. One important setting here is temperature. I usually keep mine low because that makes the output more deterministic. Basically, it makes sure the AI sticks to what I asked for. If you raise the temperature, the output becomes more creative, which can be great for things like creative writing, but for image generation, it can sometimes give you things you didn't ask for. The other setting you'll want to adjust is max length. Now here's the deal with LLMs. They take into account three things: the system prompt, the user prompt, and the AI's own output. All of that counts toward the max length. If you're getting results that don't match your prompt, it could be that the system prompt is getting cut off because your max length is too low. But if you set it too high, your system could slow down. For me, the best value for image generation is 9984. That way, I can have a long system prompt and still get a cohesive output. And finally, just like with the persona node, make sure is enabled is set to true. This activates the node so it actually runs during generation. Alright, let's talk about the prompt group. The first node here is the system prompt node, and honestly, you don't need to change this. Even if you tweak it, it doesn't really make much of a difference, so I'd recommend just leaving it as is. The second node is where you add your own prompt manually. That, along with the system prompt, gets combined in the third node and then fed into the K sampler as the positive prompt. Now, Lumina 2 also works with a negative prompt. And for this, I haven't changed anything. I just kept it on the default. But even at default, it still does a pretty good job. If you're not getting the results you want, try playing around with different negative prompts to refine your output. The rest of this is pretty standard. You've got your K sampler, your empty latent node, and your SDXL resolutions node, which lets you adjust the resolution and orientation of your generated image. Now, a quick thing about the K sampler and the model sampler. These two work together, so you want to balance them properly. If you're using high step counts, then keep your model sampler high as well. But if you're using lower step counts, like 20 or below, then drop your model sampling to 4 or lower. From what I've tested, CFG4 gives me really solid results, but you can push it up to 6 if you want. That just means your results might be a little different. Not necessarily bad, just different. For steps, I usually go somewhere between 25 to 35, and it's fast. Like, faster than I expected. It actually ran quicker than FluxDef with the Turbo LoRa, which is kind of impressive. Alright, let's generate our first image. First, I'll make sure the loader group and the text to image group are both active. Everything else should be off for now. I'm also going to bypass the large language model because for this test, I want to use my own prompt. So I'll set the prompt switch to 1, which tells it to use my manual input instead of the LLM. The prompt I'm using is a woman in a black jumpsuit with a whip in her hand. The woman is on a black motorcycle. This is a really vague prompt. I'm not specifying the background, time of day, mood, art style, or anything else. Just the subject. Before I queue it up, I'll set the resolution to 16 by 9, and now let's see what we get. The composition looks good, but look at her arm. This is way off. It looks like the bike is merging with her, and the whip, completely missing. Instead, there's this weird material coming out of her hands, which is definitely not what we asked for. Let's try another simple prompt to see how it handles minimal instructions. This time, I'm going with a woman in a black dress standing in the street. Just keeping it really simple to see how much creative freedom Lumina takes. And honestly, it seems like it does better when there's less information. It has more room to interpret and fill in the details naturally. But what happens if we switch to an LLM-generated prompt? So for this next test, I'll enable the LLM prompt group and change the prompt switch to 2, which means we're now using an AI-generated prompt instead of my manual input. For the subject, I'm keeping the same base idea, and for style, I'm setting it to realistic. Let's see what happens. I kind of expected this because I'm basically using a Flux system prompt, and from what I can tell, Lumina doesn't handle Flux style prompts very well. I'll tweak this later to see if we can get better results. But for now, let's move on to layered prompts. Layered prompts are great for complex scenes because instead of writing everything as one long description, you break it down into layers, each focusing on a different element of the image. This makes the AI process the details more accurately. I'm still using the same base prompt, so we should still end up with a woman on a bike with a whip. But now it's broken down into more detailed layers. And yeah, this does look better, but it's still not quite there. I increased the steps to 35 and that helped. It's definitely an improvement. So I knew the results were going to be subpar, and that's not the model's fault at all. It's 100% on me, because I didn't prompt it the right way. So how do we fix this? We fix it by writing better prompts. And not just better, structured, detailed prompts that actually tell Lumina what we want. Not too long, like the ones we use for Flux, but also not so short that the model just fills in the gaps however it wants. Now, here's the thing. If your prompt is vague, Lumina has a tendency to default to digital art, like we saw with the woman on the bike. And that's why the key to getting exactly what you want is clarity. If your prompt is short, you need to be super clear about the style of the image, or the model will just guess. Let me break it down before we move forward. I use a simple formula to structure my prompts, and there are a few important steps you need to follow to get the best possible results. So here's where I always start, with the adjective, subject, and art style. There's more to it, but this is the foundation. First, you need to clearly define what you want to see and how you want it to look. The adjective describes the subject's appearance or mood. Things like majestic, fierce, serene, futuristic. The subject is the main focus of the image, so a warrior, astronaut, cat, cityscape, whatever you want to generate. And the art style tells Lumina how to render the image. It could be anime, photorealistic, cyberpunk, oil painting, Pixar style. Whatever fits your vision. Let me give you an example. Let's say I want a short anime style prompt. I could write something like, a confident warrior woman in an anime style. Here, the adjective is confident, the subject is warrior woman, and the art style is anime. Simple, right? Now, let's switch things up and go for a photorealistic style instead. I could say, a hyper-realistic photograph of an elderly man with deep wrinkles and expressive eyes. In this case, the subject is elderly man and the art style is hyper-realistic photograph. If you don't specify an art style, Lumina just guesses, which is how you end up with unpredictable results, like this and this. So that's the first step. The next thing we need to add to the prompt is composition and details. Because once you have your subject and style, you also need to tell Lumina how the image should look. There are a few key things that go into this: pose and action, lighting, background details, and mood or aesthetic keywords. The pose and action describes what the subject is doing. Are they standing confidently, sitting on a rooftop, mid-action with a sword? Adding this kind of detail makes a huge difference in the final image. Lighting helps define the mood. Think warm sunlight, dramatic shadows, neon glow. Each of these changes the feeling of the image completely. Background details give the image depth. Instead of just a plain, empty space, you can add elements like a burning battlefield, a futuristic cityscape, or a dark forest. And finally, mood and aesthetic keywords reinforce the atmosphere. Words like cinematic, tranquil, intense, whimsical help guide the model toward the style and emotion you're looking for. Let's take a look at an image with a dynamic action pose to break this down. I'm going to use anime style again for this example. Here's the prompt. A fierce samurai in an anime style, mid-swing with his katana, wearing traditional red armor. His hair flows in the wind. Dramatic backlighting makes his silhouette stand out against a burning battlefield. The scene is intense and cinematic, with glowing embers in the air. Now, right away, you might notice something. The image doesn't actually look like anime, and in a second, you'll see why that happened and how we can fix it as we go through this guide. So let's break this prompt down. The pose and action here is mid-swing with a katana. The lighting is dramatic backlighting, which helps define the silhouette. The background details include a burning battlefield and glowing embers setting the scene. And the mood and aesthetics are intense and cinematic, giving it that dramatic, action-packed feel. So even though all the elements are there, Lumina still didn't create an anime-style image. Why? Well, we'll get to that in just a second. But first, let's go through another example. This time with a photorealistic portrait using soft lighting. Here's the prompt. A close-up portrait of a young woman with light brown hair, looking to the right, illuminated by warm, golden sunlight. Her hair is gently tousled, catching the light and creating a halo effect around her head. The background is dark and out of focus, enhancing the contrast between her illuminated face and the shadows. The mood is serene and contemplative. Let's break this one down too. The pose and action is looking to the right. The lighting is warm, golden sunlight, which creates a soft, natural effect. The background details are dark and out of focus, which helps bring attention to the subject. And the mood and aesthetics are serene and contemplative, which gives the image a quiet, thoughtful atmosphere. Now, why does adding all these details matter? Because it helps Lumina stay on track and not make random choices that might not match what you had in mind. Next, we need to talk about something really important: how to adjust for different art styles. Different styles have specific characteristics, and if you want Lumina to follow a particular style, you need to describe it clearly. This is exactly why the anime image I generated earlier didn't actually look like anime. I said the style should be anime, but I didn't include the key features that actually define the anime look. The easiest way to explain this is with examples. Let's start with anime style. Here's the prompt: a cute cat sitting on a rooftop, anime style, with big expressive eyes and a glowing city skyline in the background. Soft cell shading, warm color palette, playful and cozy mood. So, the art style is anime. But what really makes it look like anime? It's the key features. Big, expressive eyes. Cell shading instead of smooth gradient. A warm, colorful palette that gives it that signature anime feel. These details push Lumina in the right direction and make sure the final image actually looks like anime instead of just a generic digital painting. Now let's try something different. Pixar 3D style. Here's the prompt: a friendly astronaut floating in space, Pixar style 3D render. He has a round, exaggerated face with large, expressive eyes and a big smile. His spacesuit is glossy white with colorful buttons. The Earth is visible behind him, glowing in the sunlight. Soft, high-quality lighting, whimsical and adventurous mood. So, the art style is Pixar style 3D, but what makes it actually look Pixar? It's these key features. A round face with exaggerated proportions. Smooth 3D textures instead of detailed, photorealistic ones. Soft, high-quality lighting that gives it that polished, movie-like finish. Exaggerated expressions that add personality and warmth. I want to quickly look at two more styles before we move on. The next one is cyberpunk digital painting. The prompt for this is: a cyberpunk mercenary with glowing blue cybernetic eyes, standing in a neon-lit alley. He wears a black trench coat with holographic details, and his mechanical arm holds a futuristic weapon. The background is a rainy cityscape filled with neon billboards and flying cars. High contrast lighting with neon glows, semi-realistic digital painting, moody and futuristic atmosphere. So the art style here is cyberpunk digital painting, and the key features that really define it are things like neon lighting, futuristic elements, and semi-realistic rendering. These are the things that tell the model, this is what cyberpunk looks like. If you don't include these kinds of details, the model might just generate a generic sci-fi character, which isn't quite the same. And finally, let's look at fantasy cinematic painting. The prompt for this is: a fierce warrior queen in a cinematic fantasy painting, standing on a battlefield with a massive sword. Her armor is ornate and battle-worn, and she has long silver hair flowing in the wind. Dramatic backlighting highlights her silhouette against a stormy sky with lightning in the distance. High contrast, moody and epic, powerful and heroic composition. The art style here is cinematic fantasy painting, and the key features that make it work are things like dramatic lighting, high contrast, detailed armor, and a stormy battlefield. Again, these are the details that guide the model. They help it understand what makes this specific art style look the way it does. Now let's talk about something really important: how to add realism for photographic styles. If you want your image to actually look like a real photograph, there are a few things you need to include in your prompt. These are lighting precision, texture details, depth and focus, and composition techniques. Let's break those down. Lighting precision is all about how light interacts with objects. So things like soft daylight, harsh neon glow, or candlelight all create very different looks. Texture details mean adding real-world textures into your description. Think about wrinkled skin, glistening raindrops, rough stone. Things that have a tactile quality that you'd expect to see in a photograph. Depth and focus are camera terms that tell the model how sharp or blurry different parts of the image should be. Things like shallow depth of field, sharp details, or a bokeh background all influence how realistic the final result looks. And finally, composition techniques reference real photography styles. So things like the rule of thirds, close-up framing, or dynamic angles help make the image feel more natural, like something that could have been taken with an actual camera. Let's look at a real example. Here's the prompt. A hyper-realistic portrait of an elderly man with deep wrinkles and expressive eyes. The lighting is soft and diffused, casting gentle highlights on his weathered skin. His silver hair is slightly unkempt, and a woolen scarf is wrapped around his neck. The background is blurred, with city lights creating a warm bokeh effect. The color palette is earthy and muted, evoking a nostalgic and introspective mood. Ultra-detailed, cinematic, documentary-style photography, shallow depth of field. So let's break this down. For lighting precision, we're saying the lighting is soft and diffused, casting gentle highlights on his weathered skin. That tells the model exactly how light should interact with the subject. For texture details, we've got deep wrinkles and expressive eyes, and his silver hair is slightly unkempt, and a woolen scarf is wrapped around his neck. These are the small, real-world details that add realism. For depth and focus, we're saying the background is blurred, with city lights creating a warm bokeh effect. And also, shallow depth of field. These tell the model how sharp the focus should be on different parts of the image. And finally, for composition techniques, we're using ultra-detailed, cinematic, documentary-style photography. That makes sure the image has the look and feel of a real documentary portrait. So when you include all of these elements, lighting precision, texture details, depth and focus, and composition techniques, you end up with something that looks way more like a real photograph. Here's how the final structure looks like. Start with adjectives, then the subject, then the style, pose and action, lighting, background, and finally mood and aesthetic keywords. This structure helps you get better, more accurate images every time. Try to keep your prompts somewhere between 50 and 150 words. That seems to be the sweet spot. And if all else fails, just use SDXL prompts. Seriously, I was surprised too. I actually added an SDXL prompt styler to the workflow just to test it, and what can I say? It works really well. I'll explain more when we get there. I'll give you both versions of the workflow to download, but moving forward, I'll be using the one with the SDXL styler. Now, let's actually put everything we've talked about into action and also see how well SDXL prompts hold up against large language prompts. The first prompt I'm testing is a hyper-realistic photo of an angry Viking dwarf with a bushy, tangled and messy full beard and a wrinkled face, standing in a medieval village in front of an army of hyper-realistic garden gnomes with shields and spears, armor. The atmosphere is dark and moody, with rain droplets bouncing off the muddy brown ground. Dim light shines through the dark clouds, creating deep shadows, bokeh effect, cinematic photography. And there it is, the final output. It actually looks amazing, even with these little, kind of cute garden gnomes. Next, I adjusted the system prompt to follow the new guidelines, so let's try it out. This time, I'm using a different prompt. A giant robot walking through a steampunk city, steam-powered planes circling the robot. For the style, I'm using fantasy and science fiction illustration by Jakub Rozorski. And just to add even more detail, I'm throwing in ink strokes. Now, let's set the switch to 2 and cue it up. And wow, it's amazing. It's not exactly a perfect match for Jakub Rozorski's art style. This is what his work actually looks like. But I think it leaned more toward the steampunk and ink strokes than the full Rozorski aesthetic. So, if you're ever in doubt, just use LLM Party with the new prompt. Like I mentioned earlier, I'm also including the Lumina 2 persona in the workflow download. Now, let's see how SDXL prompts perform with this model. I actually grabbed this next prompt straight from Civit just to see if it makes a difference. Origami Master Chief with a gun. The Halo Hero Master Chief, USCD. 77, TC Pelican dropship in the background, battlefield, trees, aliens, folded in intricate paper design. I'm setting the switch back to 1 and also disabling the LLM prompt group. I also changed the style from base to origami. Now, here's something to keep in mind about how the SDXL styler works. If you leave the style on base, that means you can manually type in whatever style you want. But if you actually want to change the style entirely, then just switch it from base to whatever you want to use. And, oh my god, this is absolutely adorable. Look at Master Chief, the trees, the dropship in the back. So yeah, SDXL prompts still work just as well as they used to. Now, let's take a look at the image-to-image group. This group works the same way as the text-to-image group. The only difference is that this one includes an upload image group. So the upload image group is made up of the load image node, which is what we'll use to upload an image. Then we have the resize image node. This is really important in case you're working with a high-resolution image. You need to make sure that whatever resolution type you select matches the image you uploaded. For example, since this image is landscape, I'm going to select landscape. And finally, the last node is the VA encode node. Let's say I want to turn this woman into a 60-year-old woman. A denoise value of 0.6 should be just fine. And there it is. It did exactly what I asked for. She went from a young woman to a 60-year-old woman. Now, if you want to quickly upscale an image, you can use the fast upscale group. This method is a bit faster because it only uses the upscale model. So it's a great option if you just want a quick resolution boost. For this, I'm using the foolhardy upscale model. All you have to do is change the upscale factor selector to whatever size you want. I'm going with 2 times upscale for now. Let me switch the image to the Viking dwarf we generated earlier and see how it turns out. And yeah, that looks pretty decent. It's fast, it's simple, and it gets the job done. Now, if you want more detail, you can use the ultimate SD Upscale group instead. Just a heads up, this will take a little longer, but the results are usually worth it. The process is pretty similar. Set your upscale factor. I'm keeping mine at 2 times, but now I'm also adjusting a few other settings. I'm still using the foolhardy model. I've set steps to 10, CFG to 4, and denoise to 0.3. Okay, this looks amazing. It definitely took longer, but you can see the extra detail it was able to add. So what do I think about this model overall? Well, it's basically like a fine-tuned SD 1.5 that's been trained with a large language model. It's not revolutionary, but it's seriously good at generating different art styles. That said, it does have its weaknesses, like hands. If you try to prompt a character holding something while doing an action, you'll probably run into weird distortions. I do think the community could fine-tune it even more and improve those issues. But for now, I wouldn't recommend using it for photorealism. It just takes way too much effort to get it to look truly realistic. Unless your prompt is really simple, even the slightest change can push it back into a more artistic direction instead. Let's go over how to get this running on your system. You have 2 options. You can download the all-in-one model, which is about 10 gigabytes, or you can download everything separately. The model, the clip, and the VAE as individual files. I'm using the GGUF version because I only have 8 gigabytes of VRAM. If you want to do the same, go to the link in the description, download the version you want. I'm using Q8 since it's only 2.7 gigabytes. And once it's downloaded, move it into the model's UNet folder. Next, you need to download the Gemma 2 model and place it in the model's text encoders folder. Then download the VAE model and put that in the model's VAE folder. If you're going with the all-in-one model, just download it from the link in the description. And once it's finished, place it in the model's checkpoints directory. If you use this version, you don't need the separate files. Just load it through the load checkpoint node instead. Now, let's install the upscaler. Open the manager, go to Model Manager, and search for foolhardy. Download the upscale model from there. I also have a full step-by-step video on how to install and use Lumina, so if you need more details, you can check that out. There's a link up here, or you can find it in the description. Alright, now once you've got everything installed, just drag the workflow into your workspace. If you're missing any nodes, open the manager, click Install Missing Nodes, select whatever is missing, and install them. After that, just restart ComfyUI and you're all set. Thanks for sticking with me this far. If you found this helpful, make sure to like the video. It really helps more people find this kind of content. And if you want more deep dives like this, don't forget to subscribe. I've got a lot more coming your way. Alright, that's it for today. See you in the next one.